Okay, let's take a quick look at this problem. It says with n equal 13, p equals 0.6, find p of at least 9 using a binomial probability table. I notice that you had a little trouble coming up with that number. The little red triangle means you didn't get it right. So what I did is I went to our book and I pulled up the binomial probability table from page 755, and we wanted the probability of at least 9, and we're talking about the probability of success is 0.6. So we want the 0.6 value for 9, 10, 11, 12, and 13. Now if you pull out your calculator and you add up these 5 amounts, they do add up to the 0.352. Okay, now we want to answer the second question that says estimate the probability using the normal distribution. If the normal distribution cannot be used, then enter capital N. And we want the probability again of at least 9. So what we need to check first is that NP is greater than or equal to 5 and NQ is greater than or equal to 5. So we pull out our calculator and we just double check it. Our N is 13, our P is 0.6, so for NP we get 7.8 and we're good. Now let's do NQ. We've got 13 times. Q is 1 minus P, so we've got 0.4. So we got 13 times 0.4, and again we get a number that is greater than or equal to 5. So using the normal distribution as an approximation is perfectly acceptable. So the first thing we want to do if we're going to use the normal distribution is we need to calculate the mean and the standard deviation. Now our mean in the binomial distribution is NP. So we're going to take N times P, and for our mu we're going to get, we already multiplied it on the calculator, we get the 7. Okay, so I'm just going to write that we have mu equal 7.8. And we need sigma, the standard deviation. And now you need to remember that the formula for the standard deviation is the square root of N times P times Q. So we can pull out our calculator and we can do that real quick. We've got 13 times P times Q equals, and now we need the square root of it. Well, let's take it to 3 places. 1.766 should be good enough. Okay, so I went and grabbed a picture to illustrate the area that we are interested in. If it is at least 9, it's 9 or greater in our distribution. So we need the z value for this, and what we need to do is, because we are approximating a continuous value from a discrete value, we need to make an adjustment. And what we will do is we will subtract 0.5. We will subtract 0.5 from the 9 so that we are sure that we're not going to omit any of the, well, it's an error correction. So 9 minus 0.5, we're going to use 8.5. And now we're going to calculate the z value. Z equals the 8.5 minus the mean, which is 7.8, and then divided by the standard deviation, 1.766. So let's get our calculator out again and do 8.5 minus 7.8 and then divide that by 1.766. And so for our z value we get, I'm going to get my point of my pen somewhere, or whoops, get it back, 0.396. There I am. So I need to go back to the table now that I have the z value of 0.396. I'm going to look in the table, and what it's going to do is it's going to give me the value to the left of my z value. So let's open back up our table. Now this table is for binomial, so I'm going to turn the page. I don't have a negative z-score, I have a positive. So I have a positive z-score, what was it? 0.396. So we got 0.3, well, we can only do to two places. Sorry about that. So we're going to have to round up that 0.396 is approximately 0.40. That's where we've got to go with that because our table only does it to two decimal places. So we go to 0.40 and we see that we get 0.6554. Okay, so this area in this region is 0.6554. But the region we want the value is the blue shaded region, so we need to take 1 minus 0.6554 and see what we get. Should be 0.3446. That should be our region under the curve. So that's the probability that we estimate using the binomial distribution. It's within reason close to this one. We got 0.352, and if we round to three places we get 0.345. So we're within 0.007 of the answer we got from the table. And that's how they wanted you to work this problem.